Hello, everyone. Good morning. My name is Marcela Quintero. I'm the Research Director for Multifunctional Landscapes at the Alliance of Biodiversity International and CIAT. And I'm happy today to present this together with my colleague, Ermias Betemerian, that works for the CRASAN C4. Both of us has been involved in the CGIAR program on water, land, and ecosystems over the past years, and we have been collaborating under the flagship on restoring degraded lands. So today we would like to share some of the lessons that we get from the work that we have together with our partners conducted on this program. So first of all, I would like to say that we want to share 6 main lessons, and that I think they're key for the work ahead and the challenges ahead that we have in restoration in Africa. So the first lesson is about the power of information to catalyze restoration actions in Africa. So WLE and its partners and funders have made a tremendous investment in developing, consolidating, and sharing soil information. So this information is not a bottleneck anymore for the design of sound and context-appropriate restoration actions. Why soils information? I mean, restoration is beyond trees. And for long-lasting restoration efforts, we need to sustain those on healthy soils. So in WLE, we made available information tools for restoration practitioners. So for example, we have made available the Global Soil Data Manager for Sub-Saharan Africa, and with hundreds of users already registered there. Also, we supported the Africa Soil Information System project that includes a soil health surveillance system. Currently, we have approximately 17 countries using the soil infrared spectral technology that is part of this soil health surveillance system. The second lesson or message that we want to communicate today is about the importance of scientific evidence for supporting investment cases in soil health restoration. And again, why soil health restoration? About 65% of the agricultural land in sub-Saharan Africa is degraded due to the poor management practices, which induce declines in soil biological, chemical, and physical quality, and this reduces the capacity of soil to support crop production and to provide other ecosystem services. So WLE has worked on building evidence on how and at what extent and in what conditions management practices improve soil health and then influence the delivery of several ecosystem services, like regulation of water flow, changes in soil biodiversity, or reduction of greenhouse gases. This is important because the primary focus in soil health management over the years has been in increasing crop productivity, but to a lesser extent in the associated environmental benefits. So given the momentum and the promotion of management practices to restore soil health is that WLE has built evidence on the environmental benefits of improving soil health as evidence to support the creation of investment cases for soil health restoration in Africa. My next message has to be with the science, the importance of science to inform action and investment. As restoration delivers multiple benefits and there is a diversity of management practices to restore soils and landscapes, there is then a critical need to start moving from general restoration investments toward investments that are more targeted, depending on the priority benefits. And those priority benefits change to one side to the other. So in this sense, science is needed to develop tools that help matching better restoration actions with the benefits of interest for the different stakeholders. So WLE advanced quite a lot on developing these tools and maps for targeting better restoration actions. So for example, we developed for Africa a map that shows us where is the highest potential to sequester carbon in agricultural lands if these are better managed and restored. Or in Ethiopia, we are finalizing the development of a tool that is called the Landscape Doctor Toolbox that help us to match different restoration options with different type of benefits depending on what is the benefits that the stakeholders wants to maximize. For example, soil erosion, crop productivity, water flows, and so on. The other aspect that we also want to bring here is regarding monitoring landscape restoration. So what happened after investment? How we can improve our accountability in terms of delivering the expected impacts of restoration. So WLE has made an important contribution in developing and implementing monitoring frameworks to assess soils at large scales with a lot of efficiency and at a lower cost. So for that, ECRAF have been combining infrared spectral technologies with remote sensing, and right now, ECRAF has supported 31 labs in 19 countries across Africa in order to improve their capacity to monitor restoration options in the field. And then my two last comment has to be with policy. I think as scientists, we are learning more on how to engage better with policy processes to support the policy implementation. So one example is that we supported the land degradation neutrality target of the UNCCD through its science policy interface. Basically and specifically, we brought together CGIAR experience on assessing soil carbon sequestration to develop guidelines that can be applied in different contexts and that can also help level the field at the moment of reporting restoration actions and achievement across different countries. And to finalize, this interface between science and policies has to be in two ways. It's not only that science informs policy implementation, but also we need policy change to amplify the power of science. So here we brought this example in Ethiopia, where soil degradation and uncertain climate conditions are really threatening smallholders and poor farmers across the countries. This means that Ethiopia, a society that is agricultural based, is struggling to produce food for a quickly growing population. So part of the solutions lies in determining the appropriate management of soil fertility for a given location. However, although this can be done rapidly through digital agriculture, agriculture is the less digitalized sector in the country and in other countries as well. And also soils and agronomy data that is in different organizations that has worked in the country for many years is not shared or not ready to be used for many. So with the support of the Ethiopian Ministry of Agriculture, we establish and we participate in a national task force to develop a soil and agronomy data sharing policy for Ethiopia. After many rounds of work in this task force, the policy was launched, and now we have a group of different organizations that are working on developing digital information systems to support more appropriate soil management and try to restore the soils in Ethiopia that are key for feeding their growing population. So with this, I would like to finalize this presentation. Thank you.